Okay, welcome to Quest Review Part 2, sections 4.1, 4.2, and so on. Okay, number 9. Again, we're going to write a system of equations to describe the situation, and then this time solve by elimination. So it's a word problem. We have to turn it into two algebra sentences, right? It's going to be a system, so it's got to be more than one equation. All right, let's see what it tells us to do. All right, Devon purchased tickets to an air show for 7 adults and 2 children. The total cost was $141. The cost of a child's ticket was $6 less than the cost of an adult's ticket. Find the price of an adult's ticket and a child's ticket. Okay, so let's start with that. Let's start with the cost of these tickets. There's a relationship here. I think it'll help us to find this relationship first. And I guess, we better find out what our x and y are. The two mystery things are what's the cost? Find the price of adult ticket and child's ticket. Okay, so let's make the adult's ticket x and the child's ticket y, because they come in that order. All right. So cost of a child's ticket was $6 less than the cost of an adult's ticket. Well, that stands to reason. The adult's ticket is more. So if we take the adult's ticket, X, and we subtract $6 from it, we'll get the price of the child's ticket. Right? Okay, so now let's see what else we have here. Devon purchased tickets to an air show for 7 adults and 2 children. The total cost was $141. See, well, we don't know what the price of the adult's ticket and the child's ticket are, but we know it totaled out to 141. So let's put 141 here. Okay, and then we've got adult tickets, X's, and the cost of those altogether, plus all of the child's tickets, which is Y, is going to equal 141. Okay, but how many adults tickets were there? Well, there were 7. Okay, how many child's tickets? 2. Okay, so 7 adult tickets plus the cost of 2 child tickets will equal $141. So we're in pretty good shape here. We've got our 2 equations. Now we're supposed to solve the problem by elimination. So we've got to make the 2 equations have their x's and y's and their constants in the same place. Alright, so to do that, we could rearrange either the top equation or the bottom equation. Well, I kind of like the way the bottom equation looks, so I'm going to rearrange the top equation. Top equation is x minus 6 equals y. I'll put our x and y on the same side, so I'm going to add a negative y to both sides. Okay, so then our x, we have x minus y minus 6 equals 0. And I'm going to get our constants on the other side, so I'll add 6 to both sides. And that gives us x minus y equals 6. Okay, so now the 2 equations are in the same form. So I can put them underneath each other. X minus y equals 6. Okay, but I can't add them yet because nothing could get eliminated here. If I added them together now, actually I can. I didn't realize it. Oh, no, I can't. No, I'm still going to have an x and a y. Still going to have an x and a y. So, what can we do to make them look, make the either the y's disappear or the x's? Let's multiply by 2. Let's multiply the second one by 2. Okay, so I think I'll write them right above. So we have 2x and then 2 times the negative y is a negative 2y. So you notice our y's will cancel out now. And then that equals 2 times 6 is 12. Okay, so now I'll add them together. And what do we get? Got 153. And that equals... So now notice, by the way, we're adding these top two. You don't want to get that mixed up. So it's the 12 plus the 141. So 153. 2y plus the negative 2y is 0. And then we have 7x plus 2x is 9x. So I'm not sure I want to recommend doing it exactly the way I'm doing it here, because this could get messy. So you want to be as neat as possible. But I only have limited room, so do what I can, right? So 9x equals 153. Divide both sides by 9. 9's cancel here. And so we have x equaling 17. Okay, so we'll stick this back into one of our equations. Let's use the easy one. The x minus 6 equals y. So we have our x, right? Which is our adult tickets. Our adult tickets cost 17 bucks. 17 minus 6 equals 11. So the children's tickets were 11. And adults equal 17. Okay, but are we done? No, because we really should check them in our second equation, which was, remember, our second equation is this one right here. So 7 times our x, which is 17, where will we do it? Let's do it up here. So 7 times 17 plus 2 times 11 has got to equal $141. So go ahead and do that on your calculator. See if I got it right or not. Okay, for number 10, 11, and 12, it says use any method to determine whether the system of linear equations have no solutions, one solution, or infinitely many solutions. And then it says also show your method. You should always show your work, so I know where you got the answers. Okay, so I'm going to look at these two equations and say, well, it wouldn't be too hard to substitute, but it would be very easy to do the elimination. And of course it would be hardest to do the graphing or the table, the numerical method. So I'm going with elimination. And to get the equations to subtract from each other, I'm just going to multiply through the top one by a -1. See if you can think of why I'm doing that. Why am I going to multiply the top one by a -1? So -1 times that, and of course -1 times that. Okay, I'll put the answer down below here. So -1 times x makes it a -x. -1 times a -2y will make it a +2y. And -1 times 0 is 0. Okay, so now I'll add them together. I get -2. And that equals 2y plus -y is 0. And 2x plus a -x is just x. So I have x plus 0 equals a -2. Or x equals a -2. Now that was easy. Okay, and then we'll stick the -2 into our original equation, which is our original equation. If you can tell or not, it's x minus 2y equals 0. So if I put in a -2 here, minus 2y equals 0. Add 2, both sides. Get a negative 2y equaling 2. Divide by negative 2. And y equals a negative 1. Okay, so our ordered pair, which I'll put up here on top, is a negative 2, negative 1. But I'm not happy until I try it in my second equation, make sure it works. Right? So we've got 2x minus 2y equals negative 2. Substitute in 2 times negative 2 minus 2 times y is a negative 1 equals a negative 2. Is that true? 2 times a negative 2 is a negative 4. Negative 2 times a negative 1 is a positive 2. And negative 2 plus a positive 2 equals a negative 2. So, that's right, negative 2 equals negative 2. And we are done. Well, are we done? We found out that actually it has one solution. Remember, that's actually what they wanted. They didn't ask us for the solution to this problem, even though I wanted everybody to figure it out. But this has one solution. Now you're probably thinking, wait a minute. That's negative 2 equals negative 2. Isn't that the sign that there's infinitely many solutions? Well, not at this point. That's when we're checking our answers. We want to see, when we stick our answer in the equation, we want to see that one side equals the other for it to be true, right? So we know that there's one solution when we get down to here. When it's x equals negative 2, then we know it's one solution. If at this point it's like 2 equals 2, or if it's 5 equals 7, you know that there's not one solution. It's either no solutions or infinitely many. And we'll talk about that again in the next problem. Okay, number 11. Again, we're using any method we want to determine whether there is one solution, infinite solutions, or no solutions to this system of equations. Okay, so my choice would be elimination, because I can just multiply the top by negative 2 and it'll match up the x. But actually I'm noticing something already. I wonder if you are, about the top equation and the bottom equation. Alright, you can tell just from kind of looking at them, there's something about them that lets you know how many solutions there are. Let's see if you can figure that out. Stop the thing and look at it and see if you can figure it out. But I'm going to keep going here. So we've got 2x plus 5y equals 10. And I'm going to drop this down. 4x plus 10y equals 20. And I'm going to multiply the top times a negative 2 so that I'll get the x's to cancel out. Okay, so negative 2 times 2x is a negative 4x. Negative 2 times 5y is a negative 10y. And negative 2 times 10 is 20. Oops, I mean a negative 20. Okay, so now I'm adding those two together. And I get 0 plus 0 equals 0. They must have both been the same equation. So now 0 equals 0. Anytime that both sides are equal, two numbers that equal each other, well, we know that that's infinite solutions. They're exactly the same line. If we look back up here, that's why I wanted you to look at it. Look back up here, you notice if you multiply the top one by 2, you'll get exactly the same equation that the bottom one is. Or if you divide the bottom one by 2, you'll get the top equation. Okay, so infinite. infinitely many. Number 12, again another one of those where we're deciding which it is. No solutions, one solution, or infinitely many. And look at it and see what you'd want to do. Well, you know, we've already got, both of them are in terms of one of the variables, right? So that would be an easy one to substitute. But I don't think it would be too hard to also use elimination. But substitution would be easier here, I think, because we don't have to rearrange the equations. So we can stick in, I think I'll just stick in this one, this y, into this y, which is x minus 5 plus 3 equals x. Okay, and now I will combine like terms. So we get x minus 2 equals x. Add a negative x to both sides. And we get negative 2 equals 0. And of course the negative 2 does not equal 0, never is going to equal 0. This will never work. So no solutions. We don't have to go any further. Okay, so now we're here at the exponents. We're going to do all the exponent problems. It says evaluate the exponential form. So I think a quick review of what we were talking about as far as exponents go is, let's say we have 3 to the 7th power. Okay, 3 is the base, 7 is the exponent, or power. And it means that the 3, the base, is multiplied times itself 7 times. Also, let's talk about negative and positive exponents. Let's say we had, let's say we had x to the 4th power. Well, x is the base, 4 is how many times, right? So we've got x times x times x times x. If we go down, x to the 3rd power. X to the 2nd power. X to the 1st power. Notice we reduce it by 1x. Basically, it's divided by 1x. If you divide x to the 4th power by 1x, you get 3 times itself. If you divide x to the 3rd power by x, you get x times x. So x to the 0 power would be 1, because x divided by 1 is, x divided by x is 1. And then x, keep going, x to the, that's supposed to be a 1. X to the negative 1 power would be 1 divided by x, which is 1 over x. Also notice that this is a reciprocal. Negative powers are reciprocals. Okay, so x to the negative 2 will divide 1 over x by x, and we get 1 over x squared. Or we get the reciprocal of the positive. If that's what I didn't mean, it's not the reciprocal of x minus x to the negative 2. It's a reciprocal of x squared. 1 over x squared is the reciprocal of x squared. So the negative powers give you the reciprocal of the positive power. So you can understand what I'm talking about there. X to the 3rd equals 1 over x to the 3rd power. The that 3 should be on the bottom there, and so on. Another way of looking at these is 1 over x divided by x is also 1 over x times x, or x to the 1 over x to the 3rd power is 1 over x times x, or x to the negative fourth power is the same as 1 over x times 1 over x times 1 over x times 1 over x. So you do have to get used to the idea that x or some variable to a negative power like x to the negative 6 is 1 over x to the 6. Okay, so now let's look at this first problem over here. We've got a negative 3 to the 0 power. Okay, the 0 power means it's 1, but it's a negative in front of it. So it would be a 3 to the 0 power is 1, and it would be negative 1. Okay, now this one, the exponent is on the parentheses. Everything inside of parentheses goes to that power. So negative 3 to the 0 power would be just 1. For instance, negative 7 x cubed y cubed over q to the 9th power p to the 100th power. That whole thing was to the 0 power. It equals 1. Not positive 1, not negative 1, but positive 1. Negative 8 to the 2nd power. So that exponent only deals with the 8. It doesn't affect the negative. So we could write it like this if we wanted to. Negative 8 to the 2nd power. Like that, because the exponent only does what affects the thing that it's touching. Alright, so this would be x 8 to the 2nd power 64, which equals negative 64. You could go straight to the negative 64. You don't have to do this intermediary stuff. Now this one is different though, because the whole thing inside is to the 2nd power. Negative 7 times negative 7 is 49. So the answer is 49. It's positive 49. Okay, so we have 8n to the 6th power times a negative 7n to the 2nd power. Now, we could, just remember the rules, and that is that we add, if we're multiplying two bases that have two of the same bases with different powers, we can just add the powers, whether they're positive or negative. But if you forget that rule, you can factor the thing out. That means put all the factors together. So let's do that. We'll go, it's 8 times n 6 of them, right? And this is times negative 7n squared. So times negative 7 n squared is n times n. So this is the easy way to do it. If you forget what the rule is, and the rule is easy, you add them in this situation. But if you forget, you count them. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have n to the 8, and then we have a negative 7 times 8, which is a negative 56. We are done. Okay, here we are again. We have x to the 5th, and that is to the 4th power, because x to the 5th is inside a parentheses, and the 4 is attached to that parentheses. And then we have times x to the 4th. So the rule for this is x to the 5th to the 4th power would be x to the 20th power times x to the 4th power times x to the 4th. And we add those two, we get x to the 24. But if we forget that, we can do this. We'll go x to the 5th times x to the 5th times x to the 5th times x to the 5th, and that's times x to the 4th, 1, 2, 3, 4. Okay, so, and then x to the fifth, well, that's 5 of them, right? 1, 2, 3, 4, 5. Okay, and there's 4 of these. There's this one, 1, 2, 3, 4. 4 times 5 is 20, so we have x to the 20th, and then we have 4 more. 1, 2, 3, 4, so x to the 24th, which is what we got before. We multiplied the 4 times the x to the 5th, because there are 4 of x to the 5th, that makes 20, plus the 4, so x to the 24th. The next one is all inside parentheses. It's a negative 5, x to the 5th, y to the 5th. And that's all to the second power. So, if you can remember the rule, each thing inside there is to the second power. So negative 5 to the second power is 25. X to the 5th to the second power, that means 2 of them. So 2 times 5 is 10. X to the 10. And then y to the 5th, there's 2 of those. 2 times 5 is 10. So it's 25 times x to the 10th, y to the 10th, or 25x to the 10th, y to the 10th. Now if you forget that, you can still factor it out. Everything inside the parentheses is to the second power, right? So we've got 2 of these. We've got negative 5 x to the 5th, y to the 5th, times negative 5 x to the 5th, y to the 5th. And then you can factor, each of those out if you want. You can go negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's one of them. And a negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, and then count them up. We've got negative 5 times negative 5, so that's 25. And we've got 10 x's. Count them up, you see there's 10, so that'd be x to the 10. We've got 10 y's. Y to the 10. 25 x to the 10, y to the 10. We got the same thing. How much longer did it take? 3 or 4 seconds? It's worth doing. Alright, the next problem, I think I'm going to have to erase. Here inside our parentheses we have 2y divided by 5. That whole thing is to the third power. So, you could remember what the rule is. So that would be 2 to the third power, y to the third power, over 5 to the third power, right? So, we've got 2 times 2 times 2, y times y times y, over 5 times 5 times 5. And that was 8y to the third over 5 times 5 is 25 times 5 is 125. Okay, so we could do it that way. Or we could try this. We'll go, alright, 2y over 5 to the third power is 2y over 5. 2y over 5. 2y over 5. You just write what it is. So that might be easier for you to figure out this way. So we've got 2 times 2 times 2, 8. Y times y times y, y to the third. And that's over 5 times 5 times 5, 125. I mean, that's the way we multiply fractions, right? So that's our answer. Okay, so now you see number 21 and 22, those have negative exponents. So it's no reason to freak out. Remember I said that the negative exponents are like the positive exponents, only the reciprocals of the positive exponents. So for instance, x to the negative 10 power equals 1 over x to the 10th power. Another aspect is, let's say we have something in parentheses. I don't know, q to the 5th, y to the negative 7th, p to the 8th over q to the negative 7, y to the 5th, p to the negative 3. And that's all to the negative 7th power. Okay, so that looks like quite a mess, right? Let me get this out of the way here. But that negative 7, that tells you to just flip the whole thing. It's the reciprocal, right? It's the reciprocal. So the reciprocal, well, if we had a reciprocal, say if I wanted the reciprocal of 1/4, the reciprocal of 1/4 is 4/1. So the reciprocal of this big mess is just you flip it over. So we would have, I'll shoot it up here, we'll have everything that's on the bottom on the top. Just rewrite it. Put exactly the same thing on top. Y to the 5th, p to the negative 3rd, over q to the 5th, y to the negative. So you have to keep it straight. I was just getting confused myself there. Okay, let's see if they match up. The top matches the bottom now, and the bottom matches the top. Okay. See, so now that whole thing is to the positive 7 power. And we just deal with it. There's 7 of these things. So if you could you want to factor that whole thing out, you can. You know, or you can use the rule. If it's on the outside of the parentheses, you multiply the 7 times each one of those exponents. It would be 7 times that negative 7 would give us q to the negative 49. And it will give us y to the 35th and p to the negative 21. And then on the bottom, it would give you q to the 35th, y to the negative 49, and p to the 56th power. And then we deal with that, you know. But, you know, you take one piece at a time. This is a complicated problem. We're not going to even get one like that. So the best thing to do with these negative powers is to flip things at first, okay? So this z to the negative 9th would become 1 over z to the 9th, right? And z to the negative 5th, well, that would become the inverse of that, which would be z to the 5th. Okay? This must be a z. So the end result of this would be z to the 5th over z to the 9th. Now we can deal with that, because on top of now we have 5 z's, right? 2, 3, 4, 5. On the bottom we have 9 of them. And you know that z divided by z equals 1, right? They cancel into each other. Or any number divided by itself cancels into itself. So let's cancel out the ones we can. There's this one, this one, this one, this one, and that one, which leaves 1 on top. You know, because z into the top and z into the bottom. You know, you can't just leave a 0 up there. It's got to be 1. Okay, so let's see how many z's we have left. 1, 2, 3, 4. So it's 1 over z to the 4th. Or another way to do it is you could just start off by saying if you have a reciprocal, if you have a fraction, you can subtract the power from the one on the denominator from the one on the numerator. So z to the negative 9th minus a negative 5th. That would equal negative 9 plus 5 is negative 4, so it would be z to the negative 4. And as you know, that equals 1 over z to the 4th. So these look scary, but they're really very simple. You just need to do a bunch of them to get the hang of it. All right, this one here, we'll immediately put it on the bottom. 1 over r to the negative 6 times t. Okay, But that r to the negative 6, well, we can switch that to the top. R to the 6th over t. And we're done. Number 23. T to the third power in the numerator, and then t to the negative 8th power in the denominator. So now if you remember the rule about what to do with the quotient with a negative, or actually anything in the denominator with you know how to divide, this is easy. But you know it's not a hard problem to begin with. So we subtract, right? So t to the third minus the exponent in the numerator, which would be denominator, minus 8. Okay, 3 minus 8 is the same as 3 plus 8, which equals t to the 11th. But if you don't remember that rule, another rule that you should remember, or aspect, or truth about this, is t to the negative 8 means 1 over t to the 8th. Right? So that means t divided by 1 over t to the 8th. So we could write that this way. T to the third divided by 1 over t to the 8th. And how do we divide fractions? Well, we turn them into multiplications, right? So we go t to the third over 1 times t to the 8th over 1, right? The reciprocal of this, 1. And that equals t to the third times t to the 8th. 3 t's times 8 t's times themselves is 11 t's times themselves. So we can just go t to the 11th. T to the 24th, t to the 24th. This is number 24. And it's in parentheses, there is x y to the 6th over x to the 4th y. Now that negative 2, if you know what to do with these negative exponents, this is easy. All we do is flip this fraction over and put x to the 4th y in the numerator and x y to the 6th in the denominator, and then we can change the exponent to a positive one, right? So, and then after that's in a positive exponent, you can see that this is the base. This base is times itself twice. It would be like this. X to the 4th y over x y to the 6th times x to the 4th y over x y to the 6th. And we look and see what we've got. So there's x times itself 4 times here, and x times itself 4 times here. So that makes x times itself 8 times. Then we have y times itself once, so that makes it 2 times. Y to the 2nd. And then on the bottom, we have x, 2 x's, so that's times itself, x squared. And then we have here, we have y to the 6th, that's y times itself 6 times. And we have y to the 6th, times itself 6 times, that's times itself. So there's 6 plus 6, there's 12 of them. Whoops, I want to do that in black. Y to the 12th. Okay, so but we're not done because we've got the same bases in the numerator as we do in the denominator. So we have to deal with that. And this this over here, that's a mistake. It shouldn't be there. Okay. So you can think, well, x to the 8th there's 8 x's times itself, and then in the denominator there's x to the 2. So we would subtract those two, and we would get x to the 6th. And then there's y to the 2 in the numerator, but y to the 12 in the denominator. So 2 of those will cancel out. This will cancel out those two, and they'll leave it 10. So we would have y to the 10th. So x to the 6th, y to the 10th is our answer. But there are other ways to do this. There are different ways this problem can be done. So here's another way. We can take care of the stuff on the inside first, if we want to. This stuff and this, the numerator and the denominator. Okay, because you can see there's x's in the numerator and in the denominator, and there's y's in the numerator and denominator. So we can rewrite this like this. We have above the fraction bar x, and then we have six y's times themselves. 1, 2, 3, 4, 5, 6. And in the numerator we have 4 x's times themselves and 1 y. And of course that's the negative 2. We haven't changed that yet. Okay, so now we can cancel out the things that are the same in both the numerator and the denominator. Like the same number into the same number equals 1. Like p divided by p equals 1, no matter what p is. Doesn't matter what p is. So we can cancel out 2 y's. Y divided by y is 1. And we can cancel out 2 x's. X divided by x is 1. Then let's count up and see how many y's we have left in the numerator. We have 1, 2, 3, 4, 5. So that would be, I'll write it over here, y to the 5th, right? And the x's in the denominator, well, there's 3. See, 1, 2, 3, so that'd be x to the 3rd. Of course, the whole thing is still to the negative 2 power. And to make it positive, we have to find the reciprocal of what's inside here. This is the base. Everything inside here is the base, and it's the negative 2. So if we put it in its reciprocal, then we can make it to the positive 2. So we would go x to the 3rd over y to the 5th. And that's to the positive 2. Okay, so now it becomes easy since it's just to the 2nd power. There's 2 of them. In the numerator, there's x times itself 3 times. And to the 2nd power, that would be twice, right? X times itself 3 times x times itself 3 times. That's 3 plus 3, that's 6 of them. Or 2 times 3. So we have x to the 6th power. In the denominator, same thing. We have 5 y's times themselves, and we square that, or we multiply that times itself. 5y times itself times 5 y's times itself, that's 10 y's. Y to the 10th. And that's our answer again. So we can just keep going with this. There's lots of different ways to do it. As long as you respect that the negative power makes something its reciprocal into the positive power. Let me say that again. Let's see. I'll say that again. Something like if we have u to the negative 1 power, that equals 1 over u. U is the base. The negative 1 is the exponent. Okay, so let's call it w. W to the negative 10th power. Well, that would equal 1 over w to the 10th power. Notice the power suddenly became positive. If we had a fraction, let's eliminate this. Like a over b, and let's say that that was to the negative 9th power. Well, all we do is flip it over, and then we have b over a, and that's to the 9th power. So whatever's in there, we turn it over. Now if there's just one number in there, say there's 15 to the negative 9th power, so it's not inside, it doesn't have to be inside anything. That would be 1 over 15 to the positive 9th power. We'll put a whole bunch of stuff inside. Let's say we had this, x to the 9th, y to the 98th power, over x to the negative 7th, y to the negative 25th. And all of that was to the negative 13th power. Well, this whole thing is the base. The reciprocal of the base would let us turn that power into a positive power. So we'll put the stuff that's on the bottom on the top. We'll go, and we're not changing it, we're just turning it over. Negative 7, that's a 7. Y to the negative 25. And then put this on the bottom. X to the 9, y to the 98. Okay, so turning it over like that, what we've changed then is this. It's now to the positive 13. And then we could deal with whatever we want to do. We could either deal with everything that's inside and simplify that first, or we could multiply the 13 times each of the exponents. So one last time. Let's do this. Oh, this is to the negative 2. Okay, so we'll do this one other time. I think I've done this before, but what the heck. Okay, so everything inside these parentheses is the base, and all of that, everything inside there, is to the negative 2 power. So what we can do is we can multiply the negative 2 times the exponents of everything inside. That would be the x's have to the 1 power, and that y would be to the 1 power, because there's no exponent on them. So negative 2 times 1 is a negative 2, so x to the negative 2. Negative 2 times 6 is negative 12, so we have y to the negative 12. And negative 2 times 4 is negative 8, x to the negative 8. Negative 2 times 1, again, is y to the negative 1. Okay, so now everything's out of the thing, but you notice that all the exponents are negative. So let's put the negative ones on the opposite side of the fraction bar, because it's reciprocal. If we make them positive, they'll be the reciprocal of it, right? So x, I'll color them, I'll circle them. X to the negative 2 becomes x to the positive 2 when it's put in the denominator. Y to the negative 12 becomes y to the positive 12 in the denominator. X to the negative 8 becomes x to the 8. Whoops, undo that black. X to the 8 in the numerator. Y to the negative 1 becomes just plain old y. Oh, wait a minute, that was supposed to be a 2. Pardon me, I don't know how I forgot that. That negative 2 over here times that 1 made that a negative 2. We put that in the numerator, and it's y to the 2. And so now we've just got to cancel things out. Let's do that with red. We've got 2 x's here, we have 8 here. So we can cancel out 2 of those x's and make it x to the 6, right? And we've got 2 y's times themselves here. We've got 12 y's times themselves here. We can cancel the other direction. We can cancel out 2 of these y's. Alright? And that will give us, in the denominator, y to the 10th. Notice we still have this, still getting the same answer. we're still getting x to the 6th, y to the 10th. So if you understand this reciprocal thing, this thing with the negative exponents, and you need to do several problems to kind of get the hang of it. So it just kind of makes an impression on your brain, and you realize it's nothing so mysterious. You won't have any trouble with these. And now we proceed to the next panel. And now we bid a fond aloha from the islands. End of the quest review.